All right, Algebraites, what we're going to do in this video is we are going to find the real roots of this equation by graphing. One method is to graph each side, but we're actually going to functionize and by placing this in standard form. What do I mean by that? Well, once I put it in standard form, I have 2x to the fourth minus 9x squared plus 4 equals 0. Functionize just means turn this into a y, and now I can graph this function right here. Then once we do that, we're actually looking for the x-intercepts. Again, if you are using Desmos, you plug it in, and then you just tap your intercepts, and boom, 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 you find out what the x values are. So we are going to look at and do exactly this, but with the TI. How do we find the x-intercepts? So over here in my TI, I'm going to place my function in one of the function slots, and then I'm going to go to graph. Now, you might find out that your window is way off, way high, way low. So one thing I want to show is that we can zoom in, and we can do so with the Z box right here. We can create a box. Notice that when my cursor shows up on my screen, it shows up at the origin. And remember, since we're only interested in the zeros, when I hit enter, I'm going to start making a box. So notice it forms a line, and if I extend it left or right, it's now going to make a box. And this is going to be my new window. So notice I got to all my x-intercepts. So when I hit enter, although I don't see the whole behavior of the function, I see the most important parts. I see the x-intercepts. So I'm going to find this x-intercept right here and this x-intercept here. So how to do that? You press second and then calc. We're going to go to number 2 to find a 0. And this asks me to find the left bound. So I don't even know where I am on my functions here. So I'm going to try to find my cursor. Oh, there you are. So I found my cursor. I'm on the left of, notice I'm on the left of this point here. That's where I want to be. So I hit enter. And I'm going to go to the right of it, which coincidentally is underneath the x-axis. And now it says take a guess, and here's my guess. So actually here it is. Here's one of my answers, is 0.707. So coming back over here, I can now place and say x is approximately 0.707. Now let me repeat that process here, but this time I'm going to find this here. So how does one do that? Well, magically delicious. We go to second, calc. I'm going to press 2 for intersect. I'm going to do the left bound. At this point, I'm to the left, so I can hit enter. And I'm going to keep going until I get to the right. There we go. I just passed it. Hard to see. Now I'm there. Now I go back one. Dun, 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 dun. There it is. Here's my other 0. It's a 2. So I come back here and say one of my other ones is exactly 2. Well, it turns out when I repeat that process, I'm going to get plus or minus this value and plus or minus this value. That is not always going to be the case, plus or minus of those. However, since I have a power of 4 right here, I know that I have upwards of 4 solutions. And I did have 4 unique solutions, plus or minus the 0.707 and plus or minus the 2. It won't always be 4 unique solutions. I could have multiplicity as an example of a function that has multiplicity. If I had x minus 2 squared and x plus 3 squared, and that was my 0, to find my solutions, this one here is a 2, and this one here would give me a negative 3, and these have multiplicities of 2. So it does have 4 solutions, but not 4 unique solutions, just to give you a heads up on that. All right, I hope that helped. Enjoy yourself, YouTube land. Fare thee well.